In this video, we'll be talking about domain and range of our relations and functions. In the relation, we have a set of ordered pairs, and sometimes the ordered pairs are so close together that they create an image on the coordinate plane. The domain of the relation is represented by the x values, so x numbers are called domain, and the range of the relation is represented by the y values. Domain and range can be written in different ways, so the notation can be different. Interval notation is showing intervals from one number to another, and they are different types of brackets and parentheses. So the brackets, including the number, if it is a solid point to start with, and let's say the domain can be from solid to solid point of the relation, so we're going to use brackets. If the points are excluded from a number, then you have a function and it ends up with an excluded value, then we have our round parentheses. So the solid dot or included value is represented by bracket. Excluded value is the rounded parenthesis. So we have interval notation from what to what. In other words, the x values that are acceptable are from what number to what number. Always lower on the left, higher on the right. So from least to greatest order. Set notation is represented by inequalities. So the values are in between what number on the left and what number on the right. So again, the left number should be less or the smallest, and then the values in between, and those are less than the biggest number. So in a set notation, we use inequalities and the less than or equal to. So if the value is included, we have equal sign. If the value is excluded, we have empty circle. So excluding the value. Let's see a few examples as we go on to see how those notations work. So let's say on the graph, I have a set of points. This is a relation that is represented by ordered pairs. We don't have an interval from something to something else. So we cannot use an interval notation in this situation. What we do use is the set notation. So if I read these points, I have 4, 1. I have 1, 4. Ordered pair -2, 1. And then -3, -3. This relation is a function. For every input, there is an output. So I can check with the vertical line test. And the domain of this relation is the x values in this relation. So if I look at my x values, -3, -2, 1, and 4. If I go from the least value and move along the x-axis, I have -3 for x, -2, 1, and 4. So the domain values are the x values, and they have to be listed in order, least to greatest. So smallest being -3, -2, 1, and 4. The range is represented by the y values. So as a set of values, we start at the bottom because the growth is up along the y-axis. So we have -3 for the y-axis. Then we have 1, which repeats 2 times, but that is only going to be listed once because it's the y value acceptable 1, and then 4. So for the range values, I have -3, then I have this 1 that I'm going to list once in a set, and I have 4. So in the set notation, we are using the set So these braces are a symbol in math for a set of numbers. So if I put commas in between, it's not an inequality. I put commas in between because they're separate values. Interval means from something to something else. Since this is not a continuous function, it is not containing interval. Here goes a linear function, straight line, it's increasing, and we have now a continuous line that has interval from the least value for x -3 to the highest 4. So this is going to be my representation of x values from -3 to 4. So that means that the domain of this function, or the possible x values on this line, are included from -3 to 4. So that's when we can use an interval. On my line, I have excluded 3 and included 4. So when I write the interval for the domain or my x values, I have to use a excluded, means round parenthesis on -3, and then up to 4 included. Okay, so when we use an interval notation, this means the values of x on my line are from -3 excluded, and number 4 is included. So that was the domain. When I go to range, I have to look at the possible values for y. So the range is the possible values for y. And they have to be listed from least to greatest. In other words, from smaller to bigger, from the bottom to the top. So that will be from -2 to 3. -2 for y will be excluded and 3 is included. So we are looking from the bottom up, from least to greatest order as the interval goes. So we have the range values in the interval from -2 to 4, all those values. So from -2 excluded, rounded parenthesis, to 4 included. That's a symbol of interval. In set notation, or as inequality, we can write that our x values are in between, so they're greater than the smallest value, but the least lower than the highest value. So in between, lowest value has to be on the left, higher on the right. So the x values are in between -3. The focus again is on domain in the inequality. So the x values will be the values here along the x-axis. Those are all the possible domain x values. They're in between -3, the lower value, and 4. Since the 4 is included, we add the equal sign. So that's what this inequality means. The x values are in between -3, lower, and 4 included. The range from -2 to 4, so we represent the range as an inequality. So now we have to say that the y values are in between -2 and 3, not 4 here. Oops. Make sure we have 3. -2 all the way up to 3. -2, then you look at the excluded circle. That was less than without an equal sign, but 3 is included. So that's when we add that equal sign. Okay, so to double check, we have our x values from -3 to 4. So the interval from -3 to 4, or the x values are from -3 to 4, -3 being excluded, 4 included. Then the range values are from -2 up to 3, from -2 to 3, the interval -2 to 3 along the y-axis, and as an equality or set notation, we have the y values in between -2, lower value, and 3, included, higher value. So the y values are from -2 to 3. Let's see more examples. So first, by looking at the line, we see a negative line. Remember, when we read the linear equation, we always go from left to right. So don't get distracted by the arrows. It's always good to cover up the ends because sometimes they can be distracted. And so this one is a decreasing or negative line. What the arrow is representing here is the continuous side. In other words, the arrow means the line doesn't stop here. It's extended. So it is going to be extension. On this end, the line stops and the value is excluded. So let's see how to look at this example. Well, if I have to look at the domain, those are the x values. So on this side, I have to stop. So the possible x value, the greatest possible x value is 2. To the left, we moving along, don't stop. In other words, it's going to be extension of the line. So the line doesn't stop here. The arrow says keep going, keep going, keep going to the left. How far? Nobody knows. So that's when we are going to use the infinity symbol, and it is negative. So our line for the x values, again, stops at the higher value 2. The highest is 2. That doesn't go up more. So the highest value for x is 2, but the lowest value, no one knows what it is. So we're going to use the negative infinity. Same for the range. There is a stopping on this side, point -3. So the lowest value for y that we can have is -3. But from -3, if we go up, we go, 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 and the arrow says don't stop, keep going. The arrow says don't stop, keep going up. How much? Nobody knows. Positive infinity. Because from bottom up, we have the growth of the numbers from negatives to 0 up onto positives up to positive infinity. So how do we record this? We have the domain is the x. X is from negative infinity to 2. So the interval, again, is from negative infinity because it is from who knows where on the negative side up to 2. Negative infinity is always round because we cannot include a number that we don't even know what it is. Up to 2, but it is again rounded because the exclusion right here, the empty circle. So the value of 2 itself is excluded. For the range, we started at -3, so there is nothing for the y-axis below -3. The line starts at -3 excluded, so not just the negative, not the -3 itself, but anything that is greater than -3 up to infinity. So for the y interval, we're going to start at -3. Always have to start at the least value, -3. and that is excluded, empty dot, and it goes up to infinity. Let's see a set notation or an inequality for this situation. So we have x values in between negative infinity up to 2, both excluded, so no equal signs there. The y values are in between, lower number being negative 3, and then higher number being way, who knows where, positive infinity. Okay, so the y values are greater than negative 3, but less than infinity. A different situation. So I have the line extended both ways. That means that if I want to look at the domain, it's not where the arrows stop. The arrow says extend both directions. So again, arrows mean extend to the right, extend to the left, extend and keep extending and extending, and nobody ever told us when to stop. So that means from negative infinity to positive infinity. That is our interval. So the x values are in between negative infinity and positive infinity. How about y values? If I focus on the range, which is the y values, again, we don't stop where the arrows are. We extend. Arrow says extend all the way, all the way, all the way to who knows where. So that would be, again, negative infinity to positive infinity. Because the line is continuous, it is pointing up and down, so it's extended both for x and y values. So the range or the y values will be from negative infinity to positive infinity as an interval, and from negative infinity to positive infinity as an inequality or set notation. Let's look at this segment. We have a segment that has a zero slope, a constant. It is not a positive or a negative, increasing or decreasing. So we have a line with the slope 0. There are no arrows, so we do have a domain interval from -4 to 3. So I can read the values from -4 to 3. So that is my domain, where -4 is the lower value and it is excluded. And then 3 is the higher value and it is included. Round for excluded, bracket for included, from -4 to 3. But then when I look at my range, my line is just going through 2 on the y-axis. So that means that all the possible values for y, or actually the only possible value for y, is 2. So it's just a number. So for the range, the only, let's say all these points, -4, 2, -3, 2, -2, 2, -1, 2, all the points on this line or on this segment will be y value 2. For every x value, the y value will be always 2 and only 2. So the only number involved is 2. How to write that as an inequality? Well, for the domain, we use x values, and they are in between -4, the lower value, to 3, where -4 is excluded, so no equal sign, but 3 is included, so we add that equal sign. The range is only 2, so that's not an equality, it's actually equation, that y equals 2. Let's see the next one. I have a curve which has a starting point and it goes, who knows where. So what does that mean? For the domain, we start at -3. So that's the lowest value of x. But then we continue, we don't stop. The arrow says go, 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 go. How far do you go? Up to infinity. So the x values or the domain go from -3 and keep going. Arrow says keep going, keep going, keep going, keep going. It doesn't tell us when to stop. So we include the number 3 and we go up to infinity. How about the range? The range is the y value 1 lowest. Okay, so the lowest value for y being -1. And then we go up because for the range we always go from least up to greatest. So the numbers grow from the bottom up. So from 1 we go, 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 and we never stop. The arrow says don't stop, keep going. So from 1 to infinity. So on the y-axis we go up and never stop. So for the range, again for the y, we start at 1 and we include that value and then we go all the way up to who knows where, infinity. As an inequality or set notation, we have x values that are in between 3, which is included, and positive infinity. For the y values or range, we have in between 1, which is included, so add the equal sign, going all the way up to the sky. That's another curve, and we have again a decreasing line. So remember, to help yourself, I would always suggest cover up the ends, because when you cover up the ends, you don't get distracted by the arrows. So the curve itself is decreasing because when we read, it's going downwards, and it is the extension that goes to the left but stops on the right. Okay, so it's a decreasing line that it's extended on the left side, but it stops on the right. Domain. Domain is from -infinity because we don't know where this line is coming from, but I know it stops here. Okay, so for the domain, we look at the x values and we know it stops here. There is nothing past the value of 4. So on the x-axis, the highest value is 4 because all the values on the left are smaller. There is nothing past 4. So we have the smallest number for x, 4, but where are we coming from? We're coming from the -infinity to 4. So the interval is from -infinity to 4. Excluding the -infinity, and then on the 4 value, we see an empty circle, so we're excluding that as well. So for the domain, the x values are in between -infinity and 4. For the range, we have to see what is the lowest value for y. The lowest value for y is -2. The -2 is the lowest value. There is nothing below -2. So -2 is the lowest value for y. And then we go up, and the arrow says, don't stop, keep going. So keep going. And where do you stop? I don't know. All the way up to infinity for y. So when we list the range, we have the interval from -2 excluded because of the empty circle up to the sky. Y values are going to be in between -2 and positive infinity. Next example, I see a curve where it increases up to the maximum point and then it turns. So we have interval that is increasing and then decreasing. So that is something that we're going to look as lessons go. At this point, we are only identifying the domain and range. So we have to see what are the possible values for x listed in this function and what are the possible values for y listed in this function. So I have negative, if I look at the x values, they're all in between -2 and +3. So those are all the numbers, positives and negatives and decimals and fractionals included on the -2 up to 3 excluded. So that's my interval right here. So I have the domain from -2 to 3 included on the side where -2 is, and the value of 3 is excluded. Okay, so from the beginning to the end, the possible x values. For the range, I have to go from the bottom, in other words, least value of the function is -3, so that's the lowest point of the function, and the greatest y value is on 4, 1, 2, 3, 4, and right here is the curve, so it is a solid curve. In other words, there are no blanks, so that 4 as being part of a curve will be included value. In other words, 0.04 with the y value 4 is on that line. So when I record my range from -3 to 4, so those are all the possible y values of this function from -3 to 4, -3 to 4, including the number 4, because the 4 is a solid point on this line. As inequality goes, x values are in between, lowest value -2, highest value 3 for x, where -2 is included, so we add that equal sign, 3 is excluded. For the y values from the bottom up, we go from -3 to 4, where again -3 is excluded, so no equal sign, 4 is solid, add the equal sign. That's an interesting example. We have number 9. Check this out. So we have a segment, then we have a gap, but then we have another segment. So 3 different segments. Check it out. For the domain, I have to include this value, and I go on from the smallest value of -4, and then check it out when I move to the right. So from the smallest value, -4, it is an interval going to the value of -1. This being excluded, it's like if I take this segment and lower it down and connect the value for x -1 will actually make it possible to include in the same interval. Then we go for the x value. And this is another connection. So for the value of 3 of this segment is excluded, but this one will connect and make it included, connected to the next segment. And that is when the maximum value is 1, 2, 3, 4, 5, and then the function stops. So when I start with the smaller value, again, smallest is -4 being excluded, I go continuously to the right. Here is the connection, so these 2 points overlap and make the value of x -1 possible. to keep going with no interruption. And then the value of 3 for x, again, being included here, will connect with the empty dot. It's like click together, and the value of x3 will keep going and make it continuous to 5. So for the domain, we go from -4 to 5, where 5 is included because the last value here we had a solid circle, and then -4 is excluded. Interesting for the range now. We are looking at -1 right here. But then from -1, there is a gap to +1. So it's not a continuous interval. So the value of -1, +1, and then when I go from +1 up, again, there is not a continuous interval, is a gap. There are no y values in between 1 and the next possible value of y, 2. Okay, so for the y values, or for the range, the only possible values are, again, not from a number to another. They're -1, 1, and 2. Okay, so there are no intervals. Here how we can write it. -1 is a possible value, and that's a symbol that we are using as a union of 1 and 2. So the range can be, for y, a set of numbers that are separate -1, 1, and 2. Set of 3 possible values. Nothing else in between. So it's not an interval from a number to another, but it's a set of numbers that are distinct. So 1, -1, and 2. Those are the only y values. For the domain, we had an interval. For the domain, we go from least to greatest value, -4 to 5, where -4 is excluded and 5 is included. So we have less than or equal to. And example number 10, the last one for this video. Let's see the domain and range of this curve. So for the domain, if I go along x-axis, I have arrow on the left and arrow on the right. That means don't stop, don't stop, don't stop, either way, from -infinity to +infinity. Don't stop along x. So if I move along and I see an arrow, I just keep going, keep going. If I see an arrow, I keep going. So the x values are in between. Oops, that's the interval notation here. So the x values are in between -infinity to +infinity. And as inequality, -infinity to +infinity. As an interval for range, we have the same thing. I look at the y-axis and I look, where's my smallest or minimum value? Where is my least value? I don't know. It says go, 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 go. So from -infinity to up, 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 who knows where? We don't know. So for the y values, we have the same situation from -infinity to +infinity. So our range or y values are going to be an interval all the way from the bottom to the top with no stopping. So the y values, again, are included in between -infinity and +infinity.